Welcome to this video. In this video we're going to go ahead and discuss the rest of section 2.7 and we're going to start to look at translations of functions. And so how do we translate, or how do we move, and how do we shift? Do we shift up, left, right? So that's kind of the idea of this video here. So what I have here is a screen. I'm going to go ahead and just start graphing some things. So for instance, let's just start off with an easy function. So y equals x squared is a classic parabola, right? It goes through the origin, and we all know what this looks like. And so the idea here is that you get certain points and you plug them into the function, and then you square it in this case, right? So for example, notice that we have the point 0, 0. So that means if x is 0, when I plug x in here, then 0 squared becomes, well, 0. So the y value is 0. Notice this point right here. Let me actually highlight it there. The point there is 2, 4. That means that x is 2. So x is 2 means that we plug 2 in here, and then 2 squared, well, that just becomes 4, and so we end up with this point on the graph. And if we continue to do that, then we get all these points that you see here, and it's just the x value again being squared. And so the idea here is we're going to play around with this equation and see how that affects the graph. Does it shift left? Does it shift right? Does it translate up? Does it translate down? What happens? So I want you to notice something here. I'm going to type the same thing, but I'm going to put x in parentheses here. So I'm going to square it. And notice it's the blue graph. It overlaps the red one. And I'm just going to go ahead and put a plus 0. And again, I'm not really changing anything. If you think about x plus 0, well, x plus 0 is just x, and so we're left with x squared. But I want to change, or I want to play around with this number, and then I kind of want you to conjecture what's happening, or I guess I want you to analyze what's happening and then make a conjecture based on the numbers that I'm plugging in. So let's say that I just change this value of 0. Now we have that red graph, and I'm just going to plug in a number here. So let me just start off with the number 1, and then I want you to just see what happens. So if I put x plus 1, notice now the graph has moved. Now how much, excuse me, my phone is going off. Now the question is, how much did it move? Now it moved obviously to the left. How much to the left? Well, if we look at this point right here, we were at the point 0 for x, right? 0, 0. And now this point right here it becomes -1, 0. So it looks, and let me actually zoom in here so we can see, and it looks like it moved over 1 unit to the left, right? And that's interesting because I put a 1 here. I put a positive 1 there, but it ended up translating the graph 1 unit to the left. Well, what if I put a positive 2? Well, look at that. From 0, it translated 2 units to the left, and it's a positive 2. So what do you think is going to happen if I put, let's say, a positive 5? Well, hopefully you're thinking that it's going to move 5 units to the left. And notice it did. In fact, it's way off the grid here. But notice that from 0, it literally translated 1, 2, 3, 4, 5 units to the left. That's interesting, considering that the number is inside the parentheses, the number inside the parentheses is a positive 5, and it's shifting it to the left. I wonder what happens, or what do you think is going to happen if I put a minus inside? So instead of a plus, what if I put minus something? So let's go with -1. Well, look at that. If I put a -1, it's shifting the graph over 1 unit to the right. If I put a -2, it's going to shift the graph 2 units to the right. And so what is going on here? Well, notice this point right here, this point 0, 0. X was 0, and so what we were doing is we were plugging in 0 here, and we were doing 0 squared is 0, right? And so now what we have is x minus 2 squared. So ask yourself, well, what's going to make this become 0 squared so we can get out of 0? And the only number that's going to make that inside 0 is 2. In other words, 2 minus 2 is 0, and then 0 squared is just 0. And notice we have that point, 2, 0. When I put this equation, y equals x plus 2 squared, notice that it shifted in the opposite direction to -2. And that's again because -2 plus 2, well, -2 plus 2 is 0, and 0 squared is 0. So what can we conjecture? Or what can you come up with? Well, hopefully you're thinking that whatever this number is on the inside of the parentheses, we're going to go ahead and shift either left or right. Now, if the number inside the parentheses is a negative, then we're going to shift to the right. If the number inside the parentheses is a positive, then we're shifting to the left. Now, let's see if we can play with this graph some more and add some other things to it. So I'm going to leave the x squared there. Now, what if I add a number on the outside of these parentheses? So I put a plus sign here. And so what if I add the number 1? Well, what happened? Well, let me take that number away, and we add that graph. The second I put a plus 1, notice that that graph now shifted up 1 unit up. And again, think about this point, 2, 1. Remember, 2 minus 2 is 0, and 0 squared is 0, and 0 plus 1 is just 1. So the y value is really just increasing by this value, or this number here. So if I put a plus 2, notice now it went up from 0 all the way up to 2. If I put a plus 3, it moves up to 3. What do you think happens if I put a minus 1? Well, hopefully you're thinking it's going to move down. And you're correct, it's going to move down. So it moved down 1 unit. If I change the number again and put a minus 2, it's going to move down 2 units. Again, if I change a number and put a minus 3, it'll move down 3 units. So what's happening? Well, hopefully you're thinking, okay, the number on the inside is going to shift the graph either left or right, depending on what that number is. And the number on the outside is going to shift the graph either up or down, depending on what that number is. So again, the number on the inside affects the horizontal shift. The number on the outside affects the vertical shift, right? And this is the number on the outside of the function itself, right? So we'll look at some other examples in just a bit. Now let's play around. So let me go back here. And in fact, let me put a minus or plus 0 just to go back to the original graph. We already know what the number on the inside does. We already know what the number on the outside does. Now I want to play around with the number in front of these parentheses. So right now the number there is just 1. Notice I typed in a 1 and nothing changed. But what happens if this number changes to 2? So if I type in a 2, look what happens. Aha, the graph became a little bit more narrow. If I put in a 3, notice the graph is now even more narrow. If I put in a 4, more narrow. If I put in a 5, narrower. If I put in 10, notice that we're super narrow. If I put in 100, well, we're really narrow. So maybe we can kind of say what's happening. Well, it turns out this number is going to affect the width of the graph, whether the graph is really narrow or whether the graph is really wide. Now the question is, well, we already know how to make it narrow. Just put really big numbers in there, right? Numbers bigger than 1. Well, what happens if I put numbers smaller than 1? Now you might be thinking like -2. Well, we'll talk about the negative in just a bit, or the negatives in just a bit, but think about a number in between 0 and 1. Maybe like a fraction like 2 over, I don't know, 7. Well, now we're making the graph really wide. Maybe 1/2, or look at 1/7, right? That's the fraction 1/7 in front, or 1/2, or 1/9. So it turns out if the number is in between 0 and 1, the graph is going to be really wide. If the graph is really wide, we call that a vertical shrink or a vertical compression. When the graph becomes narrow like this, we call that a vertical stretch, right? That is a vertical stretch. So the number in front is going to affect the width of the graph. Now let's talk about that negative. Well, if I just throw a negative in here, boom, all it did was it just reflected the graph across the x-axis there. So it really didn't do anything special. The negative again is not going to do anything but just reflect it or mirror it, opening it downwards. So even if I put a 1/2 and I make it negative, it's a wider graph. The 1/2 makes it wider, but the negative just makes it go in a down, or open up downward, I should say. Okay, so we've played around with the quadratic equation, or I'm sorry, the quadratic itself, and we've played around with the parent function x squared. Let's look at some other ones. So let me erase that, let me erase this. This applies to anything. So y equals Let's go with the square root function. This is a good one. So the square root function of x just looks something like this. All right, looks something like this. Now the question is, well, what happens if I put a number inside the square root? Like, in other words, x minus a number. Now, being that it's minus, let's go with 2. Again, notice that the number on the inside is going to, remember, shift the function left or right. And we do the opposite. So if it's minus 2, we're going to shift it 2 units to the right. Okay, so it did that. If I put a number on the outside, remember that number on the outside of the function is going to either move it up or down. So if I put plus 3, it should move it up 3. And notice it did again, right there. It's at 3. Okay, so let's now put a number. Let's now put a number in front. So if I put a number in front of the parentheses, remember if I put a really big number, it's going to be a vertical stretch. So imagine grabbing this graph and then stretching it up vertically. So like, let me put 4. And look at that. I grabbed the graph and I literally stretched it up vertically. So it looks like that. Let me put a smaller number like 2, right? So again, that's 1. The second I change that number to 2, boom, we stretch it vertically. Now let me put a negative. Remember, what is the negative going to do? The negative is just going to reflect it downward. So if I put a negative, all of a sudden now it's going in the opposite, or maybe it's reflected, right? We just reflected in it. Now it's going downward. Okay, so how do I vertically compress or vertically shrink? Well, remember we had to put a number between 0 and 1, so like a fraction. So let's start off, I guess, with 1/2. So 1 divided by 2. And notice that. Let me actually erase that really quick so you can see the difference. That's 1, but the second I put divided by 2, notice now we're literally grabbing the function and then vertically compressing it. In other words, we're pushing it downward. And it looks a little bit skinnier or maybe more narrow. But I kind of want to stay away from the words narrow and wide. And again, this applies to any function at all. If we take a look at just y equals x cubed. Y equals x cubed, again, looks something like this. Now if we play around with it, y equals, let's see, parentheses, and then we're going to have a cube function. We're going to put x in here. Again, if I do a plus 3, think about what's going to happen. So if I put plus 3 inside, hopefully you're thinking it's going to shift the graph 3 units to the left. And look at that. It did that. If I put a number on the outside, like let's say minus, let's go with 2, it's going to move that graph 2 units down from where it was. And notice now it's 2 units lower. In fact, this point right here, the dead center point, 0, 0, is now right here. Notice that the point, and I can't really quite get it, there we go, is -3, that means 3 to the left, and then 2 down. Now, the second I start to put some numbers in front, like a 2, remember, if I put big numbers, I'm going to stretch this thing vertically. So if I put 4, notice the graph has now been stretched vertically. If I put a fraction like 1/2, notice the graph is wider, right? Or it's been vertically compressed or vertically shrunk, as your textbook calls it. So again, we're going to go ahead in the next video and kind of just write all these things down so that you have them in your notes. But I hope this visual helped. I hope you got to see kind of how these graphs play together as we manipulate things that are within the function and then things that are outside that function. So stay tuned for the next video.